Hello students, this is Mr. T, and we are working on a project today. We are doing homework 8.1B, I believe is what we're doing. So you should have a blank copy of that, and you should have an answer key to that. Those are available on our LMS through Moodle, so you should be able to find that. So remember, stay curious. All right, so here's what the key looks like. You have a key like this. Remember, we're going to be doing, this is all in contingent of my impedance triangle. My hypotenuse is going to be z, and then the factor that changes and goes up and down here on the vertical axis is going to be my inductive reactance, or x of L. Then my linear function, all these problems, is going to be r, and it's going to just be horizontal. We have angle theta and we have angle phi. And eta angle and eta phi are just the difference. 90 is how you would calculate the other angles. So let's take a look now. We're going to be doing problems 11 through 20. I'm going to look at each one of those, so hopefully this will be beneficial to you. So let's take a look at the first problem here. What we have here is we have, this is what's in that circuit. On problem 11, as we look at this problem, the parts that are given in this equation are, let's get that down. You have an x of L, which is 16.8 k ohm. You have a theta, which is 34.4, and we are going to be looking for a resistance and our total impedance, as well as the phi. We're looking for phi in this last one right here, not theta. So that's going to be the other angle, which is phi. So let's take a look, see what we got here. If I want to find out what r is, I have to use this equation that we figure out from the triangle. Is that the theta, the tangent theta, is going to be the ratio of the y over the x of L over r. So that's got this equation. If I'm solving for r, I just swap out r for tangent theta. And then when we do that, we're taking our given values, which were 16.8 or 1600 ohms, and divide that by the tangent of 34.4, and we come up with a resistance of 24.4 k ohm. And then if I want to figure out z, my total impedance, is I'm going to use Pythagorean Theorem. So I'm going to take the square of my resistor times the square of my inductive reactance, and that's going to give me the hypotenuse of that triangle, which is 29.7 k ohms. And then I want to calculate the angle phi, and phi is going to be 90 degrees minus theta, which is 55.6 degrees. So that is problem number 17, or number 11. So let's go to problem number 12. Again, that same triangle that's in your homework, that same problem there. And what we are seeing here is the information we have here on this problem is that my total impedance is 31.4 k ohms. My theta is 14.3 degrees, and I'm looking to solve for resistance and for my inductive reactance and for angle phi. So in order for me to do that, is we're looking at the ratio of r over zt. That's going to be the cosine tangent. So if I want to solve for r, I basically take r, and it's going to be the cosine theta times zt. And I go along and do that, and my answer comes out to be 30.42 k ohms. By just doing this equation here, we see right here. And then we are going to take a look here at doing the x of L. So x of L is sine theta times zt. So I just substitute that formula with the actual values, and my answer comes out to be 7.76 k ohms. Then if I want to calculate for phi, I keep writing theta, but this angle is going to be phi. Calculating for phi, it's going to be 90 degrees minus 14.3 degrees, and my phi angle comes out to be 75.7 degrees. So that solves for problem 12. Let's take a look at 13. 13, we are, what's given to us is 106 ohms and a phi angle of 29.6 degrees. So we solve for theta by taking 90 degrees minus phi, which was 29.6. And our angle for theta comes out to be 60.4 degrees. And then now we're going to solve for the x of L, because that's what we're looking to solve for x of L. So the tangent theta is equal to opposite over adjacent, or y over x. And if I solve for x of L, my formula becomes x of L is equal to the tangent theta times r, and I just replace those values, the tangent of 64.4 times 106 ohms, and my inductive reactance, or x of L, is 186.5 ohms, and that's the answer for x of L. And then I want to figure out the total impedance, which is this ZT, which is going to be this line up here all the way across. And so we know that we're going to use Pythagorean Theorem. So we take the square of r plus the square of x of L. We add those up and we take the square root of those two numbers summed together, and we come up with 214 ohms. Moving on, let's take a look at problem number 14. In problem 14, the values given is are the resistor and the inductive reactance. So that's going to be r and x of L. So if I want to solve for the total impedance, I use Pythagorean Theorem again. I take the square root of the squares. So square 5.11 plus 3.23. Square those, add them up, take the square root of that. And I know that my values are in K, so I know when I finally get this number is that the unit is going to be K ohms, and that's what we have here. Solve for theta. Theta is going to be equal to the inverse tangent of x of L over r, and that's going to be 45.4 degrees. That's what the formula you see here. And then if I solve for phi, I just merely take the 90 degrees minus the theta, and I come up with the phi, which is 44.6 degrees. Let's look at number 15. 15 is my two given values are x of L, which is 89.9 k ohms, which is here. My ZT here, which is my hypotenuse, is 125 k ohms. So I am going to solve for resistance by taking the square of the total impedance minus the square of the inductive reactance. That value comes out to be 87.8 k ohms, if you will. Now I want to solve my theta. My theta is going to be the ratio of the x of L over ZT, the inverse sign of that. So that's where I got this formula. I sub the 89.k over 124 or 125k, and I get a degree of 45.4 degrees. And then if I want to solve for phi, I take again 90 degrees minus that 45.4. And on problem number 15, phi is going to be 44.6 degrees. All right, check your key for that. Problem number 16. Problem 16, we have a total impedance of 112.3 megohm. We have a theta of 38.2 degrees, and we're going to solve for resistance in x of L and theta. So if I want to solve for resistance, take the sine theta times ZT, and sine theta plus ZT, so the sine of 38.2 degrees times 112.3 meg ohms, and my resistance here, my linear function here going horizontally, is going to be 69.23 meg ohm. I take the x of L, I want to solve for x of L, so I take the ZT, which was 112.3 meg ohm. I square that, subtract it by the resistance, and that value comes out to be 88 meg ohm. That's problem number 16, so let me double check that. Yes. So this value here is I sort of goofed this up here. I got my numbers reversed, so let me fix that. And I think if I do 69.2 meg ohm, my numbers should come out right. And so the answer for the x of L is going to be this number here. And then a phi again is just you take the 90 degrees minus the opposite angle, then you get the 51.8 degrees. Moving on, let's take a look at 17. And 17, we have a given value for the total overall impedance of 245 k ohms, and my phi is 53.4 degrees. And when I look at that, the easiest thing I'm going to solve for is just going to be this theta angle, which is 90 minus 53.4. I get 36.6 degrees. And then once I have that figured out, I can figure out my x of L by taking the sine of theta, this 36.6 degrees, times my z, which is 245. Sub those numbers, and then my x of L is this number, 246.1 k ohm. And then finally, I can solve for my resistance. That looks like a square. We'll get rid of that. So my resistance is just going to be simply my R is equal to the square root of the total impedance squared minus the x of L squared. When I come up with the difference of those squares, I square root it, and I come up with a resistance of 196.7 k ohm. Moving on to number 18. Let's see. We're going to look at number 18. The given value here again is on that problem in that chart is the given value is 43.2 k ohms, and the theta is 27.9 k ohm. We are charged to find out the value of x of L and the overall impedance and angle phi. So again, where all this stuff is going back to this triangle, it's going back to that chart that had those trig functions on there. If I want to solve the tangent theta, is this going to be x of L over R? So if I want to solve for x of L, I simply take x of L as I take the tangent theta times the R. I'm subbing the numbers here, the 27.9 degree, take the tangent of that minus the, times the actual resistance, and that value is x of L. Now I can use Pythagorean Theorem, because I could take the square of the resistor, and I could take the square of the inductive reactance, take the sum of those, take the square root of that, and come up with 48.88 for my ZT. And then my phi is going to be 90 degrees minus 27.9, and that comes out to be 62.1. Let's take a look at 19. 19 is the given values are here. X of L is 45.6 megohm. Phi is 5.7 degrees, so not a whole lot of so this is almost a 90 degree angle here, so we're going to figure that out here in just a second. So in order for me to calculate for theta, is I take the 90 minus 5.7, so my theta is 84.3 degrees. I want to take the tangent theta, I want to solve for R, so I take the x of L over tangent theta. So the 45.6 megohm, which was the given value, divided by the tangent of 83.6, is going to make this a 44.55 megohm. And then to calculate for ZT, as you see down here at the bottom, calculate for ZT, we just take the squares of the resistor and the square of the inductive reactance. Okay, take the square root of those sums, and we get 45.8 degrees. So that should solve those. And then finally, in this last one here, this is going to be for problem 30. This is my given values. As I've got 31.7 gigohms, ZT overall total impedance of 40.5 gigohms. We have a resistance we're going to find, and a theta we're going to find, and a phi we're going to find. So in order to do that, the first thing we'll do is we'll look at this x of L value. So this x of L is just going to be my ZT squared minus my resistance squared. So I square those two values, find the difference, take the square root of that, and I should have 25.2 gigohm. And then I want to solve for theta. So theta is going to be the inverse tangent of x of L over R. Replace the values there, and I get an angle which is 38.5 degrees. And I want to find the angle phi, 90 degrees minus 38.5 5 degrees is equal to 51.4 degrees. I hope this is helpful to you. This should help answer any questions you have on the answer key. If you have more questions, I'll see you in lab.